Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to graph transformed logarithmic functions. The instructions for the example we're working on is as follows. For the given function, for the given log function, what we're going to do first is find the intercepts of the parent function. After finding the intercept of the parent function, we're to proceed to describe the transformations on the parent function. Describe the transformations. And then after that, we're to use the intercepts and the transformations to sketch the graph of the function. And then after sketching the graph, we are to find the domain, range, asymptotes, and end behavior. Okay? Alright, so let's say we have the logarithmic function y equals the natural log, that's log base e, okay, negative natural log of negative x plus 1 minus 2. Alright, so let's say this is a logarithmic function we want to answer all these questions for. Alright, let's get started. So let's go ahead and rewrite the function. We have y equals negative ln of x plus 1 minus 2. So let's start by finding the intercepts of the parent function. Okay, so with the parent function for this will be y equals the natural logarithm of x. So let's find the intercepts. To find the intercepts, let's look for the y-intercept first. To find the y-intercept, we are going to set x to 0 and solve that. Okay, so we are going to have y equals the natural logarithm of 0. And the natural logarithm of 0 is undefined. If we think about the domain constraints of the natural logarithmic function, it's anything bigger than 0. Okay, so this is undefined. So that basically tells us that we have no y-intercepts. So the y-intercept is none. Alright, so how about the x-intercepts? If you notice, for the y-intercept we set x to 0. Now if we want to find the x-intercept, can you guess what the process is going to be? We're going to go ahead and set y to 0. Okay, so for the x-intercept, we're going to set the other coordinates to 0. So set y to 0. Okay, let's see what that looks like. We have the original function y equals ln x. So now we set y to 0. We'll have 0 equals the natural logarithm of x. Alright, so to get rid of natural logarithm, we're going to use its inverse. This is log base e. The base is e. Imagine as though there's an invisible e here. So what we're going to do is exponentiate both sides using e as the basis of our exponentiation. Alright, so put a big E on the left and a big E on the right. And then we're going to have e to the 0, a little 0, equals e to the ln x. Now e and ln are inverses, so they cancel each other out. Okay, and then e to the 0th power is just 1. So we can see here that our x-intercept is 1. Okay, now that we have that down, we're going to go ahead and proceed to describe the transformations. Okay, All right, let's do that. Now, to describe the transformations, we need to know what certain variables are, namely a, b, h, and k, the signs of a, b, and then what the value of h and k are. That will help us to describe what the transformations are. All right, so to guide us, we're going to write down the transformational form of our logarithmic function underneath it. So we're going to have y equals a times the natural logarithm of b times x minus h plus k. All right. So let's start by taking a look at the reflections. So the sign of a and b will tell us what the reflections are. So for the reflections, let's see what we have. We're going to um, let's look at a sign of a first. If you notice, a is negative, so what does that mean? That means we're going to reflect vertically across the x-axis. Why are we doing that? Since a is negative, or a is less than 0. Okay? If a is negative, you reflect vertically. How about b? B is negative also, so that basically means we're going to reflect horizontally across the y-axis. Why is that? It is because b is negative, or you can say since b is less than 0. Alright, so these are the two reflections that we have in this problem. How about our shifts? For our shifts, we're going to look at h and k and their signs. We have x plus 1, so that means we're going to shift 1 unit to the left. Why is that? Since our h value is negative 1. Remember, for h, you always do the opposite, okay? That's why you have the minus here. It means opposite. And then for your vertical shifts, we're going to move 2 units down. Why we're moving 2 units down is because of the k value, since k is equal to negative 2. All right? So there goes our transformations, and there goes our the parent function and the intercepts. All right? So another thing that's going to help us to graph the function is the vertical asymptote of the parent function. So you just have to remember that for all parent log functions, you have a vertical asymptote at the y-axis. That's why y-intercept is none. So your vertical asymptote for the parent function is x equals 0, namely the y-axis. Okay, so let's go ahead and set up our coordinate system, and then we're going to graph this function right now. So there goes our y-axis, and then we're going to put our x-axis right in the center. Okay, so let's go ahead and start by graphing our original vertical asymptotes. Change colors, let's make this blue. So our original vertical asymptote is right on the y-axis as indicated earlier. So that's our original vertical asymptote. Let's make it a little bit thicker so you can see that. Alright, and then let's label that. This line we just drew right here is our original vertical asymptote. Alright, it's not the final one, it's the original vertical asymptote. Okay, and then we know what the x-intercept is. The x-intercept is positive 1. So let's calibrate our x-axis. So this is our x-axis right here. And this is our y-axis, of course. It has the vertical asymptote sitting right on top of it. Okay, so let's see. 1, 2, 3 is 1. 1, 2, 3 is 2. 1, 2, 3 is 3. So that's 1, 2, 3. Okay, and the other way, 1, 2, 3 is 1, negative 1. 1, 2, 3, negative 2. 1, 2, 3, negative 3. And then I'm going to shift 2 units down. Alright, so this is, let's call this 1, 1, 2, 2. 1, 2, 3. All right, and then going down, 3 right here. Going down, -1, 1 to -2, and -3. So we have the vertical asymptote, and then let's go ahead and graph the x-intercept. I'm going to start with red for the original. Okay, so the x-intercept is 1 right here. All right, so what we're going to do is we're going to draw a sketch the logarithmic function. So the logarithmic function just looks something like this. That's the general pattern of the logarithmic function. So we're going to sketch that right here. So do not touch the asymptote. Okay, you get really close to it, but don't touch across it. Okay, let's start from this point right here, down, and then this one goes. It's just a sketch of what the log function looks like. All right, put your arrows on it. Okay, let me do that again. Let's make this one dotted since that's the parent one. It's not actually what we're looking for. So let's make it dotted. Dot, dot, dot. Okay, so there you have it. This is the original y equals ln x. Now we're going to start to apply our reflections and shifts on this graph right here. Okay, so what we're going to do is play around with the graph, the intercept, and the vertical asymptote, and we'll be able to know what the final product looks like. All right, so we have a vertical reflection up and down. So what does that look like? If we have a vertical reflection, that basically means that the portion on the top is going to end up on the bottom, and the portion on the bottom is going to end up on the top. The vertical asymptotes will remain exactly where it is because the portion on the top will go to the bottom, and the bottom goes to the top, and you end up with exactly the same line. All right. So let's go ahead and do the reflection. So it's going to look something like this. Instead of increasing, it's now going to be decreasing. Right there, and then it curves. It's just a sketch, okay? Alright, so what is this line we just drew? This is y equals negative ln x. Okay, what we did is we reflected vertically across the x-axis, and that is because we have a negative a value. You see how the a is negative here? It was positive 1 here before, but now it's negative. So to reflect that change, we reflect vertically. Now we still have another reflection. We also have a horizontal reflection across the y-axis because b is negative. So what will that look like? Well, we can illustrate that just by reflecting the line across the y-axis. Alright, so everything on the right will end up on the left. We have nothing on the left, so nothing end up on the right. Okay, so this point that's on positive 1, if we reflect it across the y-axis, it will end up at -1. Alright, and then we're going to draw the green function that has been reflected vertically across the y-axis. So let's go ahead and sketch that. Starting from the asymptote, you just descend to your new x-intercept, and then just follow that general pattern of your natural logarithmic function. Sketch it again. So it's just a sketch of the general pattern that the natural logarithmic function follows. So just keeps decreasing that way. Alright, so what do we have now? What equation is this for this function we just reflected? This one is now going to be y equals negative ln because it's been reflected downwards, and then since it's been reflected horizontally, we have to put a negative for the b value inside the parentheses. Okay? So something like that. We can write that using, let's just use parentheses. So it's going to be the natural logarithm of negative x. Okay? Alright, now we're going to go ahead and do the shifts. If you take a look at the shifts or translations, we have to shift the graph 1 unit to the left and 2 units down. Now to do that, we're just simply going to move the asymptote and this intercept by these specified values here. Alright? So let's start with the asymptote. This vertical line that we have right here, we're going to move it 1 unit to the right and 2 units down. So if you go 1 unit to the right, it's going to end up, I picked the wrong thing. Select the vertical asymptote. Alright, so you move it 1 unit to the right. If you move it 1 unit to the right, and then if you move it 2 units down, since it's a vertical line, if you move it any units up or down, it's not going to have any effect. It's going to remain exactly where it's at. Okay, so if we move this line 1 unit to the right and 2 units down, is going to be right here. So let's draw our final or actual vertical asymptote at this time. Let's make it green. So this is our final vertical asymptote right here. So we had the original, and now we have the final vertical asymptote. Okay, so let's specify that. This is our final vertical asymptote. Vertical asymptote. Okay, and then now look at the intercept. Let's deal with that one. So we have the intercept right here. So we're going to move it 1 unit to the left. Takes it right here, and then move it 2 units down. 1, 2, right here. That's where the new this intercept right here gets moved over here. Okay, so let's go ahead and sketch the graph. We're going to copy this purple line on this using this intercept and this point right here. So what's going to happen is that the line is going to get really close to the new vertical asymptote. It's not going to be solid since it's the final answer. Okay, so it's going to get solid. It's going to move right here to the line. Alright, move the label out of the way. And then this one is just going to descend downwards, following the general pattern of your natural logarithmic function. Okay, so something like that. Okay, so that's what you have. There you have it. So let's write down what the equation of this line, the final line, is. This is going to be y equals negative because of the reflection downwards, and then minus because of the reflection side to side. X, we shifted it 1 unit to the left, so that's plus 1. And then we shifted it 2 units down, so we have another minus 2 out here, and that's your final result. Okay, so all the dotted lines are just lines to help us to arrive at the final product, which is the black one that we have here. Okay, so let's go ahead and state what the domain and range is. We just focus our attention on the black line. For the domain, you notice that the black line goes from negative infinity all the way to the vertical asymptote, which is -1. So you can write it as negative infinity to -1. Remember, your domain is the horizontal span of your graph. How wide is it? Or you can write it as x is less than -1. Okay, because this black line is to the left of -1. The range is how high can you go and how low can you go. So for the range, this graph goes down forever. Even though it goes down at a slow rate, it still goes down forever. So negative infinity, and it goes up forever. If you look at the arrow pointing up, it goes up forever. Remember, your range is the vertical span of your graph. Okay, or you can write this as all rails because it spans the entire y-axis. Alright, asymptote. What are the asymptotes of this function, the transformed function? We only have a vertical asymptote, and that is at x equals 1, so we have -1. So vertical asymptote is the line x equals -1. There's your vertical asymptote. How about the end behavior? We have a left end behavior. We notice that it's decreasing to the left, so the left end behavior is described as the limit as x approaches negative infinity of the function. Since it decreases forever, your answer will be negative infinity. Okay? So that's how you graph transformed logarithmic functions.